Alright, so here is our chapter review video for the chapter 14 test. So first we're going to go through, what I want you to do is kind of pause the video, go through these 8 situations, and all you're doing is you're listing out if it is a permutation, if it is a combination, or if it is neither event. Alright, so just for these first 8, pause it, come back and do it. Alright, so now that you've done that, let's go through these situations. We have a list of possible ways of placing people in a row for a photograph. So how am I going to figure out what this is? Well, the possible ways of placing people in a row. That tells me that order matters, so that is a permutation. Number 2, a list of all possible poker hands. In this one, possible poker hands is kind of your key. Order doesn't matter in poker. So since order doesn't matter, that is going to be our combination. So it's a combo. Alright, number 3, a list of all possible basketball teams formed from a squad of 12 men, each of whom is versatile enough to play any position. That right there is your key to it being a combination. Alright, number 4, a list of possible ways of placing books on a shelf. Well, if you're shelving books, typically that matters. Again, placing 8 different books on a shelf, so that's your permutation. Right, selection of books from a reading list containing 9 books. Does it matter how I read the books? No, I just need to pick 3. I need to choose 3. So possible selections, 3 books containing 9 books. Again, this is more a situation. Order not matter. So that's another combo. 3 digits in which no digits are repeated. So since there's no repetition, some of you may have said neither. That's one way to do it, but we're ordering the digits, so it's actually technically a permutation. It can be, since they're not repeated, that's where we get that from. 7 contestants, first, second, and third place winners. This tells you that the order matters. There's an order to the event, so it's a permutation. And finally, we have the list of possible committees. Committees being your key word here to shoot for a combo. Alright, so that's kind of just picking situations. If you want to go and do these, you can, but you don't have to. This is where we're going to solve. So now let's think about each situation. You're required to read 5 books from a list of 12. How many ways can you select those books? Well, we just talked about that above. So reading 5 books from a list of 12, order doesn't matter. That's our combo. So how many total? N, R, I need that. So total, 12. I'm reading 5. So put that into your combo, your NCR, which is going to be 12, choose 5. Alright, well, pop it in your calculator, don't remember. Again, you put 12 in first, math, go to probability, and we want a combination, make sure you choose the combination. We get 792 different ways to read them. Next one. We've got a license plate. So again, license plate, remember those problems are like passwords. Must have 1 letter, not I. So it cannot be I or O. So that means 26 minus 2 options. I've got 24. Followed by 4 digits. So 1, 2, 3, 4. 4 digits, it can be, so it's a number, a number, a number, a number. So that's 0 to 9. Which means you have 10 total options. So 10, 10, 10, 10. And finally, a different letter, not I or O again. So not equal to I or O, and not equal to first letter. So it can't be the first letter, so then we're left 1 more. So 24 options, take away 1 more. So then we're left with that. Multiply all these options together. And what do we get? So we do 24 times 10 times 10 times 10 times 10. 53. 552. 0, 0, 0, 0. Alright, moving on. Next one. So this was neither. How many different ways can a committee of 4 students be formed from 10? Committee being your key here, that's a combo. We don't care who's on the committee. Well, N, that's total, 10 students. R, how many do you want? You want 4. So 10, choose 4. So again, popping it in your calculator, we want 10, math probability, choosing 4. So 210 different committees. Alright, moving along. Again, you should probably try these before and then go ahead and check your answer. How many different homes are available if a builder has a choice of 5 basic floor plans, 3 roof styles, and 2 styles of siding? So that sounds like we have a bunch of things going on. We're probably going to use that fundamental counting theorem. Same thing here, fundamental counting theorem. FCT. So 5 floor plans times what? We've got roof styles. We've got 3 of those. Times siding. So 5 times 3 times 2, 30 different things. Alright, so let's box some answers here. So far we've done combinations and counting. Hopefully we get a permutation in here soon. Alright, number 13 is kind of a tricky one. We've got a math class preparing for its final exam. There's 11 girls, 10 boys in the class. How many different study groups can you have of 2 girls and 2 boys? So there's 2 events going on here. We've got 11 girls and we want 2 in each group. We have 10 boys in the class and 2 boys can be in the groups. But these groups go together. So this is actually combinations, but we're going to multiply them. So times 2. So 11 girls, we're choosing 2. We're going to multiply that by the event that we have 10 boys, and we choose 2 of those. So this, again, this is my girl group, the girls in the group, and this is the boys in the group. So what does that give us? Our first one, we get 55 ways, and we're going to multiply it by 45. So that's how I would put those in, and then eventually 55 times 45 gives us 2475. That's how many different groups of 4 can be made of 2 girls, 2 boys. Alright, a group of 25 interested students show up to discuss spring fling. From the group, a chairman, vice chairman, and secretary must be selected. That's your key word here to knowing that this is a permutation, because you have ordered positions. So how many do we have? We have n, there's 25 people. How many positions are there? There's 1, 2, and 3. So then I'm going to do NPR, and that's 25 total. We're picking 3 for the position. So again, just like combinations, instead we're doing 25, arrow over to probability, and then PR. Make sure that you choose the one with the P. So we got 13,800. Alright, moving along. Number 15 here. How many different pizzas can be made with the following toppings? Now remember, with toppings, we can include and not include. So be careful there. So we got sausage, so that's 2. Pepperoni, 2. Mushroom, 2. Green peppers, 2. And onions, 2. We got 2 times 2 times 2 times 2 times 2. Or 2 to the 5th power, which ends up being 32 different ways. Alright, so that was also a neither. That was more of a counting problem, considering the different ways. Alright, moving on. Here's where things get a little bit different. Roll a pair of dice. So we're doing probability of a sum of dice are 6. So probably the sum of dice is 6. Or you roll at least 1 5. So there's two events going on here. There's a probability of the sum of 6. And then we have that or. Remember, or means add, plus probability that we have at least 1 5. However, you need to ask yourself, is there mutual overlap in these events? So the question becomes the probability is it mutual or not? So is there overlap? So do these two events have overlap? Well, let's figure that out. Well, sum of 6, at least 1 5. Pair of dice tells us we need to list out all the options. So if I roll a pair of dice, I can get, okay, again, this is where I'm going to move over here. 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Now 2 1, 2 3, and so on. So make sure that you list these out. Oops, 2 3, 2 4, 2 5, 2 6. All right, 3 1. And 4. And 5. And finally 6. 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. Oops. So the question is sum of 6. We need to know if there's a sum of 6. So go through, figure out which ones to add to 6. Well, 1 plus 1 doesn't. But if we go down the list, I know 1 plus 5 does. Well, 2 plus something, 2 plus 4 does. Nothing else. Well, what about 3 plus 3 does? And now we're on the flips. Let's see, 4 plus 2, same thing over there, but they're different orders. 5 plus 1, and those would all be them. So how many options do I have there? Well, I've got 1, 2, 3, 4, 5 options. Out of how many? Well, 6 by 6, that's 36 total dice rolls. Add on at least 1 5. So here's where you can find, if you use two different colors, you can find overlap here. So at least 1 5. Well, there's a 5 in here. Notice that overlapped. There's a 5 here. Alright. Where else? There's a 5 here. We've got a 5 here. We got a 5 there. There's another overlap. We got a 5, a 5, a 5, a 5, a 5, and a 5 here. So how many 5s are there total? Well, consider all the pinks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 out of 36. But we did have that mutual overlap. So what does that mean? Well, we need to subtract probability of both events, the mutual. In this case, that was 1, 2. We had minus 2 out of 36 events. So add together here 5 plus 11, that gives us 16, minus 2 brings us back down to 14 out of 36, which is 7 out of 18. And that's our probability of rolling that event. All right, 3 more probability questions here. 17. UIC is 60% of commuters, 50% are female, 30% are female commuters, and we're randomly selecting what's the probability that they're female or a commuter. So again, probability of female or a commuter. So we need to take these two probabilities, add them together, and select out the overlap. So we have probability of female. Add on the probability of a commuter. And again, subtract out that mutual overlap. So the probability of a female commuter. Alright, so in this case we're given these percentages. So let's figure out probability of female, 50%, so 50. We're going to add on commuters, that was 60% are commuters, and subtract out the overlap, 30. So what does that give us? 60, that's 110 minus 30. So 110 minus 30, we get 80. So a grand total of 80%. Alright? And moving on, we have two more problems here. We have odds. So odds in favor of winning are 5 to 1. So odds in favor are 4 to 1. Now we got to convert this to probability. Well, how do you do that? Winning. We want winning the race, so that tells me I want 4. So I want 4 out of the total options. Now total options, how do we get those? That's adding the odds. So 4 out of 4 plus 1 gives me 4/5 that Seabiscuit will win the race. And that's how you find the probability. Similarly, we can work backwards from that. So what if we're given the probability? So probability that the Bears win is 2/3. So 2/3 is winning to what? What's losing then? Well, if winning is 2/3, then the probability of losing equals 1 minus the probability of winning. So 1 minus 2/3 is 1/3. So over 1/3. If I want odds that they win the Super Bowl, I just need to get rid of the denominators. So odds in favor are 2 to 1. What about the odds against? Well, that's just flipping. Odds against are 1 to 2. So we just flip those. Alright, so that is the basic kind of review for you. Now, we're going to have some worksheets for you to do as well as book work. Again, you can never practice this stuff enough because it is all in the wording.